Breathe slowly, and let the noise of the day dissolve into stillness. Above you, the night unfolds vast, patient, and alive with quiet motion. Each point of light is a story written across time, each shimmer a whisper from the ancient fabric of creation. Tonight we drift gently into one of those stories, the tale of a traveler from beyond the stars, a fragment of another sun, a messenger from distant beginnings. As we follow its silent arc across the sky, we will listen not just to the science of its motion, but to the poetry within it, the rhythm of gravity, the patience of light, the soft pulse of time itself. Let the universe slow around you. Feel its breath align with yours. The journey is long, but unhurried. A quiet crossing through the ocean of space. If you enjoy gentle explorations like this, stay a while. Let curiosity be your guide, and drift with us among the stars. The void opens softly. The hush settles across the cosmic sea, silent, vast, infinite. Light appears, not the daylight of our morning sky, but the first glimmer of stars, being born the faintest pulse of brilliance in the darkness of space. Across eons, clouds of hydrogen and helium collapsed under their own weight, igniting nuclear fires and transforming into stars. In that ancient moment, the universe took its breath, and light became the storyteller of time. From that great beginning, a journey began, slow, relentless, unceasing. Billions of years passed in silence, as galaxies spun and stars flickered, as planets coalesced and dust settled into shape. Then somewhere, among those billions, a fragment was born far from our sun, a small icy body, once bound to a distant star, and yet destined for travel. It drifted away, cast forth into the interstellar sea, carried by gravity and chance across light years of emptiness. And now in our own celestial neighborhood, it glows for a fleeting instant. We find it in the quiet fields of space among stars, too faint to notice at first glance. It is called 3I, Atlas, the third confirmed interstellar object ever observed, passing through our solar system. Its discovery, on the 1st of July 2025, by the Earth-based Atlas Survey Telescope in Chile, announced that this visitor comes from beyond our sun's domain. We welcome it not just as data on a screen, but as a messenger from somewhere else amid the stars. It is moving too fast to remain here. Its orbit is hyperbolic, meaning it will not loop around the sun, but simply pass through and depart again, leaving only traces of its passage behind. And though its nucleus may only span a few hundred yards to a mile in diameter, wrapped in a fuzzy cloud of ice and dust, its journey spans billions of years and thousands of trillions of miles. Breathe slowly. Let your mind drift along with its motion. Imagine the silence. It has known the silent travel through darkness, past stars, past nebulae, past planets we cannot count. Yet here it is, entering our system, brushing past our star, before continuing outward into the unknown. In its passage we glimpse the vastness, that we are but one small world, and that space flows around us, indifferent, yet full of possibility. Our gaze turns inward now, to this visitor's arrival. The Atlas Survey Program, that same name meaning last alert for asteroids threatening Earth, was not built to chase cosmic wanderers, but to protect our planet. Yet in that very function, it became a watchtower. And from that watchtower we encountered something unanticipated. an object born around another star, coming our way like a message in a bottle cast across the galaxy. We pause at the image of Earth giving rise to eyes that watch the heavens. The domes open at dusk, cameras swivel light sensors, stare into darkness. In the quiet of night, technicians sip coffee eyes, flicker across data, the hum of electronics, as restful as a lullaby. And somewhere, that fragment from somewhere else creeps into the field of view, a subtle shift among thousands of frames. The tension grows so softly you almost don't notice. A pixel changes. The line moves. A dot that should have stayed still drifts. It should be part of our solar system. It should orbit the Sunday, but it does not. It passes. It transcends. It is leaving, and yet for the moment it is here. That single moment, so small, is mighty in its consequence. It tells us that our cosmic home is not alone, that there are visitors, that time carries things from other places into our view. We open our hearts to curiosity, to the recognition that what we see is both alien and intimately connected. The darkness of space may be still, but within it are motions, secrets, stories. And so the Traveler 3I, Atlas, draws our attention. And we, watching from this pale blue dot, pause to listen. We allow our thoughts to wander outward, past the sun, past the orbit of Mars, past the distant Kuiper belt, and into the interstellar night. There is no need for fear, only wonder, only a soft turning of the mind toward vast horizons. In this moment we sense our place. We sense that we are observers and participants in a larger dance. The cosmos does not await our presence, it moves on. But for a brief instant, we are part of its movement. And that is enough. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. The sky at night stretches out like a boundless dark sea. Under that canopy, a network of eyes rests. At the summit of Chile's Rio Hurtado, the Atlas Asteroid Terrestrial Impact Last Alert System Array stirs under the first stars. Giant lenses, open shutters, freeze the moment. And each second, the sky is scanned for the unusual, the fleeting, the unknown. The hum of electronics and the soft red glow of control monitors form a background lullaby for those who look up and wait. On the night of July 1st, 2025, those eyes captured what seemed like nothing more than an unremarkable dot, magnitude 18, faint and lonely, sitting in the rich star fields near the constellation Sagittarius. In the digital archive of celestial snapshots, it was an ordinary registration. But the talent of observation lies in the quiet differences. A pixel that moves, a position that shifts, a value that escapes the expected. As astronomers reviewed consecutive frames, a subtle anomaly emerged. This speck advanced across the starry background, not in orbit, but in passage. At first, the data were tested quietly. Was it an asteroid? A distant comet? A glitch? The computations revealed a path unfamiliar. Not an ellipse, not a circle, but a hyperbola. That tells a story. This object is not bound to our Sunday. It comes from beyond. It merely passes through. The calculations traced its inbound speed at tens of kilometers per second in familiar units over 20 miles every second. For a moment, one imagines a cosmic messenger racing across the emptiness, indifferent to our world's equations. The room where the scientists worked felt still. Screens glowed numbers. Scrolled colleagues murmured, "It doesn't fit," one voice whispered. In the lounge, a coffee cooled beside a notebook. This is not a moment of loud proclamations, but of hushed recognition. The same device built to spot threats, near-Earth asteroids that might one day collide with our planet, had instead found something astonishing. The design of Atlas to monitor the skies for danger. The outcome, a pure gift of wonder. Meanwhile, the object's path was traced back into archival images. Other telescopes around the world, including the Zwicky Transient Facility in California and various observatories across Chile, showed pre-discovery sightings from late June. The pieces fit together. The mystery object now had designation 3I, Atlas, the third known interstellar object ever documented. Up until that point, only two others, 1I, Oumuamua in 2017, and 2-1, Borisov in 2019, had been seen passing through our solar system. This time the discovery came early enough to inspire something more, a chance to watch the visitor awaken. As the observers turned their sights outward, the motion of 3I, Atlas, began to reveal its character. Instead of being captured by our sun's gravity, it edged past, skimming the central star's influence, and then racing outward again. The hyperbolic orbit is a signature of an object, unbound one, not birthed in our system's nursery, but flung across cosmic expanses possibly for billions of years. Some scientists propose it may have taken flights past stars through interstellar clouds between arms of the Milky Way, a solitary flight that ended for a moment in our glimpse. In those frames, one sees not just a dot, but a whisper of passage. The sky's background stars remain fixed. The visitor shifts. Light passes through dust. The tracking software picks it up. It moves with intention, though intention in this case is the pure physics of motion. The flow of time becomes visible. The night breathes with expectation. One wonders where this object has come from, what star, what system, what epoch once housed it, and where it will go. What stories it carries encoded in its ice and dust. The change in tone is subtle. From what is it to where is it from? And what might it tell us? For even as the dot glides through space, the human heart stirs with question. In the dark control rooms, the professionals become poets of data. They commit to knowing, to charting the unknown, yet simultaneously they yield to the vastness of what remains mysterious. Knowledge and mystery share the same breath here. Through Chile's clear skies, the domes of Atlas swivel slowly. Outside, the mountain air is cold. A faint wind brushes bare rock. Inside, the cameras click one after another, capturing the same patch of sky hundreds of times each night, looking for motion. A meteor passes. A satellite drifts. But occasionally, as on that night, something extraordinary slips in. And when the algorithm flags an anomaly, the human mind leans in. The silence is bright with meaning. Then came the realization. The object was traveling about 60 miles per second, relative to the sun's frame. That means roughly 200,000 miles an hour. For context, if the moon were at that speed, it would cross the Pacific in an hour. This visitor is not bound. It will leave. The mathematics place it on an open trajectory, pointing back toward the densest part of our galaxy. Its direction suggests origins perhaps near the galactic center, or deep within the Milky Way's thick disk, a wanderer born long before Earth, long before our Sunday. Still, this moment carries no alarm. The object is distant. It poses no threat. Its approach to Earth will not be dangerously close. Scientists confirm its minimal risk, and so the emotional tone shifts. The tension of unexpected discovery gives way to awe at the fact that we are witnessing something so rare, so beautiful. The normal business of sky surveys becomes extraordinary. The vigilant becomes the enchanted. It was not loud. There were no celebratory fireworks. A single line of code turned green. A pixel glowed differently. Just like that, humanity glimpsed through the screen of observation into the infinite. This is the quiet power of science. It is still, it is soft, but it is vast. As the chapter closes, the gaze moves from the monitors back to the sky. We imagine standing outside under the Chilean stars looking upward. The Milky Way arcs across the heavens. The mountain silhouette is dark against the sky, and in that darkness, a faint new visitor curves past us, crossing from one side of the sky to the other. We hold our breath, then exhale. And now, as the universe drifts back into silence, may your mind rest in the calm between stars. The night is never truly empty. Even when clouds withdraw and the stars return, there are countless glimmers. The human eye cannot see slow-moving comets, drifting asteroids, pieces of rock smaller than mountains, yet larger than cities. Each one circles the sun in quiet persistence, following invisible tracks of gravity. They are the ancient dust of creation, the crumbs left behind after the banquet of planet-making. Long before we learned to dream of other worlds, we built machines to watch the sky for danger. The Asteroid Terrestrial Impact Last Alert System Atlas was one of them. A name like a myth, a giant holding the heavens on his shoulders. But the real Atlas is neither divine nor dramatic. It is a pair of telescopes built by human hands, standing watch over the night like twin sentinels. The system began in Hawaii, resting on the volcanic slopes of Haleakala on Maui and Mauna Loa on the Big Island. From those peaks, the telescope scanned nearly the entire visible sky several times each night. Each image captures millions of stars. A pattern of light recorded, then compared to the next. If any object shifts position even by a fraction of a pixel, the system notices. The computers flag it. The watchers verify it. And thus, from a series of patient comparisons, the dynamic universe reveals itself. It is not fast work. There is no noise, no rush. Each night, the domes open at twilight, and the machines hum awake. The atmosphere at that height is thin and clean. Winds brush the dome's surface. Inside the sensors, cool to cryogenic temperatures, the CCD cameras ready to catch the faintest glimmer. The telescope doesn't stare, it sweeps. From horizon to horizon, it collects a tapestry of points, a frozen snapshot of the entire vault above. And so on that unassuming night, in mid-2025, Atlas performed as it always did, scanning, storing, comparing. But within those frames lay something extraordinary. A faint traveler, smaller than a mountain, moving too swiftly to belong to the Sunday. It had been seen before, but unnoticed. Only when Atlas checked the same field again, hours later, did the difference appear. A single dot had moved, just slightly, barely enough to matter. And yet in that difference a universe of meaning waited. This is how discovery often begins, not in drama but in diligence. While the world slept, the Earth's mechanical eyes blinked. Somewhere among the billion points of light, one of them shifted. When the data reached the computers in the morning, a line of code flagged it an unknown. The astronomers paused. The image didn't match anything in the catalogue. They cross-checked the data brightness motion trajectory. The object's track was long and shallow, not the usual arc of an asteroid. When they plotted the orbit, the math told a quiet truth: it was not coming back. The trajectory was open, not bound. The velocity was greater than the escape speed of the Sun's gravity, more than 45 miles per second, at its closest approach. That single revelation transformed a routine observation into something rare, an interstellar encounter. The scientists at the University of Hawaii and the NASA Planetary Defense Coordination Office had designed Atlas as a safeguard, an early warning network for potentially hazardous asteroids. It could detect objects as small as 100 feet wide, giving days or weeks of notice before a possible impact. But this time, the system had caught something far more peaceful, an interstellar messenger passing harmlessly through our celestial neighborhood. In the days that followed, other telescopes turned their gaze to confirm what Atlas had seen. The Pan-STARRS Observatory on Haleakala, the Zwicky Transient Facility in California, and the European Southern Observatories Network in Chile all joined in. Together, they painted a picture of the object's path, a gentle curve swinging around the Sun, inbound from the direction of Sagittarius and outbound toward the northern constellation of Hercules. The calculations labeled it formally as 3I, Atlas, the third interstellar object ever discovered. Imagine for a moment what that means. Our solar system has existed for over 4.5 billion years, orbiting in the spiral arm of the Milky Way. In all that time, only 3 known travelers from beyond have been recognized. Oumuamua in 2017, Borisov in 2019, and now Atlas in 2025. 3 points of contact across cosmic time. 3 visitors wandering from other stars, carrying secrets of alien worlds in their icy grains. The odds of finding one such object are staggering. Space between stars is not empty. It is filled with dust debris and the remnants of long-ago collisions. But the distances are so immense that even billions of these fragments rarely cross paths with another solar system. To detect one requires timing, patience, and a little luck. Atlas had been built for vigilance. Discovery was its quiet reward. Inside the control room, the air hums faintly with the sound of cooling fans. Screens flicker, displaying lists of numbers and blinking coordinates. To the untrained eye, it looks abstract, endless streams of code. But to those who understand it, it is the language of the cosmos. Every coordinate marks a position, every timestamp a heartbeat of light from space. The watchers translate it into understanding, turning data into discovery. And yet, beneath all the precision, there is something profoundly human. Each observation is an act of care, a gesture of attention toward the unknown. We build machines to see what we cannot, but the impulse that drives them is pure curiosity. It is the same spirit that led our ancestors to map the stars by hand, to draw constellations from memory, to navigate by their glow. Atlas is simply the modern expression of an ancient instinct to look up and to wonder what is out there. In the stillness of those nights, as the domes rotate and the instruments record, there is a rhythm to it, a pulse that mirrors our own. The earth spins beneath the stars wheel above, and within that motion knowledge accumulates grain by grain, photon by photon. It is the slowest kind of revelation, the kind that asks for patience. And patience is rewarded. For when 3I, Atlas, appeared faint as a breath, it arrived as if answering an unspoken question. Are we alone in this cosmic expanse? Not entirely. The universe, it seems, does send us visitors, though they come without intention, without message, only motion. They remind us that the boundaries between star systems are not walls, but tides. Matter drifts, time carries, and occasionally, two distant worlds cross paths. As the days after discovery unfolded, astronomers coordinated to track the visitor. Observatories across continents synchronized their measurements. They shared images, refined orbits, compared brightness. The collaboration itself became part of the story, humanity acting as one set of eyes. From Hawaii to South Africa, from Chile to the Canary Islands, the same faint smudge crossed identical skies. Each location caught a different angle, a different echo of its light. Together, the data formed a complete picture, an object roughly 1 mile wide, likely rich in volatile ices, developing a coma as it neared the warmth of the Sunday. In those early days, it brightened slowly, a ghostly blur against the background stars. Hubble and the European Southern Observatory confirmed a faint tail, suggesting it was active, venting gases as sunlight touched its frozen crust. That alone set it apart from Oumuamua, which showed no signs of outgassing. 3I, Atlas, was alive with motion-breathing vapor into space, a true comet, from beyond the sun's reach. The more the scientists learned, the deeper the wonder grew. Every new observation was a note in a cosmic symphony, data points, forming melodies of understanding. And yet beneath the numbers, there was always the hush of perspective. This object had traveled for millions of years through interstellar night before this brief moment of visibility. We caught it for a heartbeat of cosmic time, then watched it drift away again. In the grand pattern of the film, the emotional curve rises here. Curiosity turned to awe. We begin to feel the immensity of what has happened, that the same technology designed for planetary defense has become a bridge to the interstellar medium. That vigilance for survival has transformed into a portal for wonder. The tension of uncertainty gives way to gratitude. Gratitude for the capacity to see, to know, to feel connection with something so far away. Now the scene fades. We see the twin domes of Atlas under a blue-black sky. Stars wheel slowly overhead. The Milky Way stretches across the horizon like a river of dust and diamond. The narrator's voice lowers to a murmur. These are the eyes of Earth, open through the night, patient and unblinking. In them we glimpse our own nature, to guard, to learn, to dream. The machines may be metal and glass, but their purpose is human. Through them, we reach out to the cosmos, and the cosmos reaches back, silently, generously, endlessly. The traveler has been found. The next step to understand its story, to trace its origin, to measure what secrets it carries will begin soon. But for now, the watchers rest. The data are stored. The stars continue their slow drift. Night folds itself around the observatories once more. The hum quiets. The instruments sleep, and high above, far beyond the faint circle of our sun's light 3I, Atlas, continues its eternal journey. A small light among countless others, moving through the infinite sea. There are nights that arrive quietly unnoticed. They do not announce themselves with thunder or spectacle. They drift in on cool air, on the steady rhythm of machines, on the sound of a breeze sliding across a mountain slope. They are nights when nothing seems to happen, and yet everything changes. The 1st of July 2025 was such a night. On the volcanic shoulder of Haleakala, the sky unfurled like a great black ocean. The last blush of sunset had long since faded. Only the afterglow lingered, a violet ribbon dissolving into indigo. The air was dry, almost scentless, but faintly electric, the kind of crisp stillness that seems to hold its breath. Inside the dome, red lights glowed softly against aluminum walls. The telescope sat poised, silent, its mirrors cooled, and aligned its computers, humming with the calm confidence of routine. Outside, the temperature hovered near freezing. At nearly 10,000 feet above the Pacific, the world below was already asleep. This was a work night like any other. The team of astronomers and technicians checked their screens, sipping coffee gone lukewarm hours ago. There was conversation, but it was hushed. Small exchanges about calibration and cloud cover, about the delicate dance of time zones that linked this observatory to its twin on Mauna Loa. A laugh here, a sigh there, but mostly there was the soft tap of keyboards and the distant hiss of wind. Above them, the stars came out one by 1,000s at first, then millions. The Milky Way stretched from horizon to horizon, a river of ancient light. Shooting stars traced thin silver lines, brief as exhaled breath. The dome rotated with the grace of a slow heartbeat. Somewhere in that panorama, a single dot was about to change our understanding of home. The telescope's nightly plan was automatic. A programmed sweep of the sky, beginning near the ecliptic, moving steadily through constellations familiar to the southern hemisphere. Each exposure lasted 30 seconds, long enough to capture the faint glow of asteroids, short enough to prevent the stars from trailing. Every image was time-stamped, archived, then cross-checked against catalogs containing decades of previous observations. To the human eye, it looked like endless repetition. But in science, repetition is how we listen for the extraordinary. Hours passed. Midnight came and went. The wind shifted slightly. The air cooled further. The faint glow from the control room windows spilled onto the snow-white dome like a heartbeat in the dark. Inside the screens scrolled numbers, coordinates, pixel intensities. The night's data grew line by line, gigabyte by gigabyte. Somewhere among those countless frames, a small light shifted its place. Not dramatically, only a whisper of movement. But movement in astronomy is meaning. Stars do not move from one image to the next. They are fixed in the celestial background. Anything that changes position between exposures is something closer, something in motion, through our own solar system. When the first comparison images were reviewed, the anomaly went unnoticed. It was subtle, buried among thousands of similar detections. Only later, as automated systems matched each frame, did the discrepancy emerge. A single alert appeared on the monitor, flagged for review uncatalogued, moving object brightness magnitude 18.5. One of the observers leaned forward. The numbers were small, almost unremarkable, but there was something odd in the motion vector. It was not following the slow curve typical of main-belt asteroids. It was straighter, faster, less obedient to the sun's pull. Strange, someone murmured. They ran the data again. Then again, slower. The computer confirmed it. The object was not bound by solar gravity. The curve of its trajectory suggested it would pass through, not around. A comet perhaps, but a comet from where no one cheered. Discovery rarely arrives with drama. It slips in like a sigh. One person took a breath, another reached for a notebook. The night went on, the dome kept turning. The hum of the instruments never faltered. The excitement when it came was quiet, an internal stirring, the recognition that something unrepeatable had just brushed past our awareness. Far below the ocean moved unseen waves curling against Maui's dark coast. Light from distant ships flickered on the horizon. But up here above, the weather time moved differently. Each second of exposure stretched into eternity. The telescope's mirrors gathered light that had traveled across trillions of miles, condensed into a signal smaller than a grain of dust. That light, caught by a sensor no larger than a fingernail, carried the story of another world. By morning, when the data were uploaded for analysis, the discovery was still invisible to most eyes. The night's files looked identical to the night before. Only when the algorithms processed them did the pattern emerge. Cross-checking known objects, none matched. Projecting orbital parameters not closed, not circular, not elliptical. The equations whispered a word that had not been used in years: hyperbolic. The astronomers reconvened. They checked the code for errors, adjusted for atmospheric distortion, recalculated the speed. The numbers held. The object's velocity relative to the sun exceeded the escape threshold. It could not have originated within the solar system. What they had found, though they did not yet know its full story, was an interstellar visitor later to be named 3I, Atlas. For the next several nights, the team verified their find. Other observatories joined in Pan-STARRS on the same island, the Zwicky Transient Facility in California, even amateur astronomers scanning the online databases for anomalies. The trail of data grew. The motion was consistent. It was real. Still, that first night remained unique, the quiet before awareness. The moment when a universe of possibility hid inside an ordinary routine. When asked later what it felt like, one of the scientists smiled. "It felt like any other night," she said softly. "We were just doing our job." And that's the beauty of it. There is something profoundly moving about that, the notion that the extraordinary lives within the ordinary. That history can change in the space between breaths without announcement or spectacle. Science often looks like waiting, like listening. It requires stillness, discipline, and a kind of reverent patience that few other acts demand. That night, humanity's instruments acted as both guardians and poets. They did not simply protect us from harm. They connected us to the greatest story unfolding around us. The same eyes that searched for threats found a message of peace, a reminder that the cosmos is vast and that we are part of it even in our smallness. Imagine standing outside the observatory as the discovery unfolded. The air is cold, thin enough to sting your lungs. The stars are so bright that the Milky Way casts shadows on the ground. You can hear almost nothing, only the faint whir of the telescope, the soft ticking of cooling metal. If you close your eyes, the world disappears. Only the pulse of the universe remains. In that silence, time slows. The night stretches on forever. And somewhere beyond the reach of vision, a comet from another star crosses into the inner solar system, gliding past the orbit of Mars, reflecting sunlight that took 8 minutes to arrive. Its ice begins to sublimate. Its tail grows faintly luminous. From our point of view, it is just a moving dot. But in truth, it is an emissary from another sun, carrying within its frozen shell the chemistry of another world. Back inside the control room, someone marks the coordinates in a logbook. Another scientist writes a quick note to colleagues overseas. The work continues unhurried, methodical. There will be confirmation later, news stories, conference papers, public excitement. But not tonight. Tonight belongs to stillness, to the quiet labor of observation. Outside dawn begins to blush at the horizon. The telescopes power down. The domes close. The astronomers stretch, gather their notes, and step out into the first pale light. The sun rises, slowly spilling gold over the ocean below. Another day begins ordinary again, as if nothing remarkable had happened at all. Yet the data stored within the observatory's servers holds a moment that will outlast every sunrise to come. It is the record of an encounter, a meeting between worlds so brief it could fit inside a heartbeat, and yet so profound it stretches across millennia. The universe rarely speaks in shouts. It whispers, and sometimes we have the tools and the patience to hear it. The next chapter of this story will follow that whisper as it becomes a song, how the scientists confirmed its nature, how telescopes across the world traced its path, and how the world began to realize that another star had sent a traveler to us. But for now, the scene remains still, a mountain wrapped in the breath of clouds, a closed dome beneath the pale blue morning, and the lingering sense that something vast has quietly passed through the human story. And though the discovery has been made, the wonder remains. For the universe does not rush. It waits. It turns. It drifts on, calm and infinite, filled with moments just like this one, unnoticed, uncelebrated, but eternal in their quiet grace. And now, as the universe drifts back into silence, may your mind rest in the calm between stars. There are moments when the universe seems to pause, as if allowing us a glimpse into its deeper mechanics. And this was one of those moments. When the data first revealed the true nature of the newly found object, the astronomers who had spent their nights sifting through oceans of numbers felt an unfamiliar stillness settle over them. The equations had spoken. The orbit was hyperbolic, a path that does not loop or close, but instead curves once and never again. The shape of freedom. The object, soon to be known as 3I Atlas, was not a captive of the Sunday, it was a visitor, a messenger from beyond, crossing through our solar system, only once before disappearing into the dark again. The recognition struck with a strange mixture of triumph and melancholy. We had found something wondrous, but it would not stay. For the scientists at the NASA Planetary Defense Coordination Office, the confirmation came quietly. The data showed that 3I Atlas was moving at a velocity far beyond the reach of solar gravity, roughly 45 miles per second, relative to the Sun faster than any asteroid born within our system. The orbit's shape betrayed its origin. Objects bound to the Sun trace ellipses. Planets, comets, and asteroids all move in loops that repeat their journeys endlessly. But 3I Atlas followed an open arc, plunging inward from the direction of the constellation Sagittarius and heading outward toward Hercules. It would enter curves slightly as it brushed past the Sun's light, and then leave, forever escaping the solar system's grasp, as easily as a leaf slips from a stream. In astronomical terms, it was on a hyperbolic trajectory, a path reserved for wanderers from other stars. News of the discovery spread among observatories across the world. Within hours, the international community of astronomers began refining the orbit, coordinating through networks that spanned continents. The European Southern Observatory, the Zwicky Transient Facility, the Canada-France-Hawaii Telescope, and even amateur astronomers joined in. They confirmed the measurements, the spectral signatures, the rate of brightness change. There was no doubt left. We were witnessing something that had come from beyond the Sun's domain, a body that might have traveled for millions, perhaps billions of years, before brushing past our small blue planet. It was humbling to think that the light now reflecting from its icy surface was sunlight that had journeyed 8 minutes from our star, only to glance briefly off this interstellar nomad and continue its eternal flight into the void. The orbit plotted across digital maps of the solar system appeared almost delicate, like a thin thread drawn across a canvas of immense scale. Starting from far below the plane of the ecliptic, the object was climbing upward, cutting through the familiar orbits of Jupiter, Mars, Earth, and Venus, before swinging close to the Sun and slinging outward again. Its path intersected the solar system at a steep angle, about 38 degrees from the planetary plane, suggesting that it had been ejected from some distant stellar nursery long ago. Perhaps a gravitational encounter with a giant planet had hurled it from its home system. Perhaps it was a fragment from the formation of another world set adrift in the galactic tide. Whatever its origin, its journey was impossibly long. It had crossed interstellar space for epochs, moving silently through the thin fog of cosmic dust, through magnetic fields, and invisible radiation through the great quiet between stars, until finally it wandered by chance into the Sun's gravitational reach. Unlike most comets, which brighten dramatically as they approach the Sun, 3I Atlas remained subdued. It displayed a faint coma, a halo of gas and dust sublimating from its surface. But the tail was subtle, as though the object carried an age-hardened shell. Spectroscopic analysis from telescopes in Chile and Spain revealed traces of water ice and carbon-rich molecules, the same building blocks that form comets within our own system. Yet the ratio of those compounds was slightly off, a signature hinting at a chemistry shaped under a different sun in a different nebula. Each molecule, each isotope, was a clue to a world we would never see. It was like reading a letter written in a language half understood. We could make out the rhythm, the feeling, but not the full story. Still, even the partial understanding was breathtaking. 3I Atlas was a cosmic time capsule, a fragment of a planetary system that might have formed before Earth was born. Somewhere billions of years ago, it had circled another star. Then, through chance and chaos, it was thrown free, an exile, from its birthplace. It drifted in darkness, for ages frozen solid, untouched by sunlight, until the faint pull of our sun captured it, for the briefest instant, bending its path into our sight. When you think about it, the odds of this encounter are staggering. Out of all the vastness of space among hundreds of billions of stars, our world just happened to be in the way. For a few precious months, Earth became a stage for observation. Telescopes tracked the interstellar visitor as it approached perihelion, the point closest to the Sun, at roughly 200 million miles from its fiery surface. At that distance, the Sun's heat began to awaken the comet's surface. Jets of vapor vented into space, forming faint tendrils of light. Astronomers compared the event to breathing after a long sleep. Instruments measured the gases released: carbon dioxide, water vapor, traces of ammonia and cyanide. All familiar, yet subtly different. The ratios didn't match those of comets, like Halley or Encke. They hinted at conditions of formation colder and farther from any star, perhaps in the outer disk of an alien solar system. Every observation deepened the awe. To some, it was like looking at the fossil of another world. To others, it was as though the galaxy itself had written us a message in ice. And yet the feeling that accompanied it was not the exuberance of conquest or discovery, but a quiet reverence. 3I Atlas reminded us that even our most advanced instruments are just candles in a cathedral of darkness. We can illuminate a fragment of the whole, but the vast majority remains unseen, untouched, mysterious. For scientists, the excitement was tempered with realism. There would be no spacecraft mission, no probe, to chase this object, as we once did with 67P, Churyumov-Gerasimenko, or with Halley's Comet. The timing was too short. By the time we recognized 3I Atlas's interstellar nature, it was already racing away, moving faster than any craft humanity could hope to match. It was a discovery meant only for observation, not for capture. Its story would be told through light alone, the photons that reached our mirrors and sensors before it vanished into the outer dark. Those photons, faint as whispers, carried within them the fingerprints of chemistry, motion, and age. When combined, they became a portrait of something we would never touch. And so, as it passed through the inner solar system, astronomers watched from Earth's night side, logging measurements into the archives that would outlive them. They recorded the comet's changing brightness, its rotation period, its fading trail as it receded from the sunday. They calculated its trajectory far into the future. Within a few years, it would cross the orbit of Neptune, then Pluto's distant path, and by the mid-2030s, it would be gone entirely, beyond even the reach of our most powerful telescopes. In a century, it would be just another invisible ember adrift between the stars. In 1,000 centuries, it would have left the galaxy's thin disk, sailing forever through interstellar night. It would never return. For a species that measures time in heartbeats and centuries, that kind of permanence feels unreal. Yet it is true, this is a one-way crossing a brief alignment of trajectories in a universe too vast to repeat itself. The thought inspires both wonder and sadness. 3I Atlas came, revealed itself, and left like a wave, lapping against a shore, carrying with it the memory of distant storms. Its passing reminds us that all things, even stars, are travelers. Gravity holds them for a time, then releases them again into the flow of the cosmos. As the comet moved outward, its brightness dwindled. The tail thinned, the coma faded. Images taken from ground-based observatories showed the once distinct glow dissolving back into the background of stars. The data streams grew quieter, the alerts less frequent. Eventually it became too faint to track. The astronomers signed off their final observations with a mixture of pride and longing. They had caught a glimpse of something ancient, measured it, named it, and watched it slip away. The catalogue entry 3I Atlas C 2025A3 would remain in the records, a line of text describing a wonder most of humanity would never know had passed above their heads. When the news reached the public, the headlines were brief. Another interstellar visitor detected. For a few days, people looked up at the sky with curiosity. Then the world moved on, as it always does. Yet for those who had witnessed it directly, the memory lingered. It was not the grandeur of the event, but its silence that stayed with them, the realization that the universe reveals its greatest miracles, not through noise or violence, but through grace. Even now, years later, the legacy of that night continues. The data from 3I Atlas has refined our understanding of how planetary systems form and evolve. The isotopic ratios of its gases provide evidence that other stars produce comets much like ours, that the chemistry of creation is shared across the galaxy. It suggests that water, organic molecules, and perhaps even the seeds of life itself may drift freely between worlds. If so, the boundaries between solar systems blur. We are not isolated islands, but parts of one cosmic ocean, exchanging fragments across the tides of space. It is a thought both humbling and comforting that what falls through our skies may carry pieces of distant suns, and that we ourselves are made of such stardust. In the end, 3I Atlas is not just a comet. It is a reminder that the universe is dynamic and interconnected, that the same physics shaping our moon's tides governs the flight of objects born around other stars. It is a reminder that chance, encounters, however brief, can reveal the entire story of creation if we are patient enough to see it. And so the object that never returns becomes a symbol of all that passes through our lives, the fleeting, the transient, the ungraspable. Like light itself, it travels endlessly, touching each observer only for an instant before moving on. It asks, nothing of us offers, no message beyond its existence. But in that existence lies everything: history, mystery, motion, and meaning. The astronomers who first noticed that tiny shift of light now look back on that discovery with a quiet smile. It was here, one said years later, and for a moment, so were we. The data they collected rests in digital archives, the images preserved in frozen pixels, the spectral graphs etched into memory. One day, perhaps centuries from now, another civilization may find that same data and run their fingers over it, tracing the echo of this interstellar traveler, marveling that humanity once looked up and saw it drift by. And as we too look up tonight, our sky seems unchanged. The stars still shine, the planets still circle, the moon still glows. Yet something has shifted within us. We know now that the space between the stars is not empty. It is a highway of travelers, a current of cosmic debris flowing endlessly across the galaxy. Somewhere out there, 3I Atlas is still moving cold, silent, unbroken, a single speck in an infinite sea. Its voyage will never end, and we will never see it again. But perhaps that is the beauty of it. Every traveler carries a lineage, and in the endless night of space 3I Atlas is not alone. Its journey, though solitary, is part of a quiet procession, a lineage of wanderers born in other solar systems, ejected by chaos, shaped by time, and drawn briefly into our gaze before slipping away again. Each one is a thread in a tapestry woven across the galaxy, connecting stars through invisible paths of motion. Astronomers call them interstellar objects, but that phrase hardly captures their elegance. They are messages of matter-silent pilgrims drifting between suns. Before Atlas, there was Oumuamua, the first, the mysterious visitor that arrived in October of 2017, discovered by the Pan-STARRS telescope not far from where Atlas would later stand. Its name, chosen from the Hawaiian language, means a messenger from afar, arriving first, and it carried that sense of poetic prophecy. Oumuamua behaved unlike anything scientists had seen before. It was small, perhaps only a few hundred feet long, but its shape defied expectation, elongated, thin, tumbling, as it crossed the inner solar system. It had no coma, no tail, no visible emission of gas. Yet, it accelerated slightly, as if propelled by sunlight itself. The mystery of its form and motion ignited years of debate. Was it a comet without ice, a fragment of shattered rock, or something more exotic? In every scenario, the conclusion was the same. It came from another star. It was the first physical proof that interstellar debris could wander into our home. Then, only 2 years later in 2019, came the second. 2I Borisov, a comet named after the amateur astronomer Gennady Borisov, who spotted it with his homemade telescope from Crimea. Unlike Oumuamua, Borisov was unmistakably cometary. It shone with a long, bright tail of gas and dust, unmistakable evidence of ice, sublimating in the warmth of our Sunday. Its spectrum revealed water, carbon monoxide, and other familiar volatiles nearly identical to comets from our own system. Yet, subtle differences hinted at its alien origin: a lower ratio of certain organic molecules, a slightly altered isotopic fingerprint. It was both familiar and foreign, like a melody we recognized, but played in a different key. Together, these two visitors formed a pattern, not an accident, but a probability. For the first time, we understood that interstellar objects were not once-in-a-lifetime miracles, but inevitable crossings. Space between the stars, though unimaginably vast, is not empty. Every young planetary system ejects millions of fragments during its violent birth, icy bodies tossed outward by giant planets, rocky shards flung beyond the gravitational grasp of their suns. Over billions of years, these fragments populate the galaxy, drifting freely, carrying with them the chemical stories of their origins. The Milky Way, when seen through this lens, becomes a living network, a river of dust and ice flowing silently between its arms. When 3I Atlas was discovered in 2025, scientists immediately recognized its significance. It was not simply another data point, but the continuation of a lineage. Its name 3I, denoting the third interstellar object, placed it beside Oumuamua and Borisov, like a chapter in an unfolding saga. Each of them revealed something new about the universe's shared architecture. Oumuamua had shown the variety of interstellar fragments, that some may be rocky dry or shaped by forces beyond our models. Borisov had confirmed the existence of true interstellar comets, volatile, rich, active, and alive with sublimation. Now Atlas bridged the two, a hybrid in behavior, both cometary and enigmatic, displaying a faint coma, but with motion and chemistry distinct from any known type. It was as if the universe were offering us a sequence of riddles, each building upon the last. In the years between Borisov and Atlas, astronomers refined their expectations. Using models of galactic dynamics and stellar evolution, they estimated that trillions of such objects might be drifting within the Milky Way, perhaps one per cubic astronomical unit in the plane of the galaxy, meaning that at any given moment, dozens of interstellar fragments are passing invisibly through our solar system. Most are too small or dark to detect mere specks of carbon and ice. But once in a generation, one grows bright enough to reveal itself, to cross the threshold between silence and sight. Atlas was one such gift. The connection among these travelers is not only physical, but symbolic. Each represents a stage in our awakening to the reality that the stars are not isolated islands. Matter circulates among them, like blood through a cosmic body. The comets and asteroids that drift between systems carry the same elements, hydrogen, carbon, oxygen, nitrogen, that form the basis of life. They are, in a sense, the veins of the galaxy, delivering chemical continuity across light years. When we speak of an interstellar bloodline, it is not just a metaphor. It is the literal circulation of material, the exchange of dust between stars, the quiet commerce of creation. In this vast galactic metabolism, every system contributes and receives. Even our own sun has likely given birth to countless fragments now drifting among the stars, unseen ambassadors of our existence. 3. Atlas thus belongs to this larger flow, one of billions of fragments traveling the Milky Way's spiral arms. Some may originate near ancient red dwarfs, others from systems long gone supernova. Some carry frozen carbon dioxide. Others hold crystalline silicates formed in stellar winds. The variety of their compositions tells us that the galaxy is not uniform, but alive with difference. When scientists study these objects, they study diversity itself, the ways in which physics, chemistry, and chance shape worlds across infinite time. The lineage also carries emotion. Each discovery rekindles that delicate human mixture of humility and wonder. For all our machines and measurements, we remain a species of dreamers, staring upward. The realization that fragments of other suns can wander into our skies feels like a message written in starlight, not addressed to us, yet somehow meant for us all the same. It reminds us that the boundaries we draw between systems and between ourselves are illusions. The universe moves as one, and we too are part of its motion. After the initial analysis of Atlas, the global astronomical community compared its spectrum to those of Oumuamua and Borisov. Its pattern of light revealed water vapor, carbon-based compounds, and faint traces of sodium and cyanogen, all consistent with cometary material. Yet subtle deviations stood out. The relative brightness of the sodium emission lines the ratios of carbon isotopes, the profile of dust particles scattering sunlight. These details suggested formation in a colder environment than that of Borisov, perhaps in the outer reaches of a disk around a smaller, dimmer star, a red dwarf, or perhaps an aging subgiant. The idea that we could read the history of a star from a pebble passing by is almost absurd, and yet that is exactly what spectroscopy allows. Light becomes language. Wavelengths become words. And through that language, we begin to see the unity of cosmic origin. The dust in 3I Atlas is not unlike the dust that once formed Earth. The ices it carries are kin to those that fed our oceans. Even the organic molecules embedded within its simple carbon chains and alcohols are precursors to life as we know it. Somewhere, far away, a system of planets may have once circled the star that birthed this comet. Perhaps it still exists. Perhaps it is gone, its light long extinguished, yet its fragments continue to wander, bearing witness to its existence. In this sense, every interstellar object is a kind of memorial, a record of creation surviving the death of its world. As months passed and Atlas began its outward journey, astronomers reflected on the broader pattern. 3 known interstellar visitors in less than a decade, a pace unthinkable before 2017. Was it coincidence or a sign of growing perception? Perhaps our instruments had finally become sensitive enough to notice what had always been there. Each discovery reinforces another truth. The universe has always been generous. It is our eyes that have learned to see. The next generation of surveys, the Vera C. Rubin Observatory in Chile, the Near-Earth Object Surveyor satellite, and countless smaller programs, promises to reveal hundreds more such travelers in the coming decades. We will map their orbits, sample their spectra, and maybe one day intercept one directly, sending a probe to taste the chemistry of another star's debris. The future of interstellar science is bright and patient, much like the objects it studies. And yet beneath all the data and anticipation, there remains the quiet poetry of the bloodline, the understanding that in watching these travelers we are watching our own reflection. For what are we, if not matter? On a journey. We too are interstellar objects temporarily arranged into consciousness. When we look at 3I Atlas, we see not a foreign thing, but a distant relative. In the calm of the observatories, the night returns to silence. The data streams settle. The world rotates under the same canopy of stars. The object drifts farther from view, becoming once again a speck in the galactic tide. But the lineage it represents continues unbroken. From Oumuamua to Borisov to Atlas. And beyond, there will be others, countless others, weaving through the sun's domain each carrying a trace of their origin, each adding a new verse to the long story of matter in motion. And so we begin to see the galaxy, not as a collection of separate suns, but as one great organism breathing across billions of years. Every star gives every star, receives every fragment, drifts a circulation of cosmic blood, unending and serene. When 3I Atlas fades completely, that truth will remain, that nothing truly ends, it only changes direction. We are all part of that flow, stars, stones, and souls alike. There is a special kind of silence in deep space. Not an absence of sound, but a fullness of stillness. The kind that hums softly in the mind when one looks too long at the stars. In that silence drifts 3I Atlas, small and pale, carrying within it a record of ancient creation. What began as a faint speck in a telescope's field is in truth a crystalline archive from another star, a relic of a world we will never see, bearing the fingerprints of an alien dawn. When light from our sun strikes it, the object awakens. Its surface, once frozen for uncounted eons, begins to shed layers of ice, releasing plumes of gas that shimmer faintly against the darkness. These jets, born of heat and light, tell us more than any photograph could. They reveal the nature of the comet's skin, the chemistry of its heart, and the long, patient story written within its dust. Astronomers peering through the lenses of the world's greatest telescopes can read these signals the way geologists read stone, every wavelength, a clue, every molecule, a syllable of a cosmic language billions of years old. Spectroscopic analysis from the Very Large Telescope in Chile, paired with ultraviolet readings from the Hubble Space Telescope, painted a picture both familiar and strange. The gases venting from 3I Atlas were composed primarily of water vapor and carbon dioxide, with traces of carbon monoxide, formaldehyde, and methanol, the same volatile compounds that shape the comets of our own solar system. Yet there was something subtly different in the balance. A lower concentration of oxygen-bearing molecules, a slightly altered isotopic ratio of carbon to hydrogen. These were not random variations. They were fingerprints, hints of a birth under different conditions, around a different star, in an environment colder, quieter, and older than our own. In the mind's eye, we can trace the story backward. Somewhere in the galaxy, perhaps 100 light-years away, a disk of dust and gas once surrounded a young sun. Within it, particles collided and merged, forming pebbles, stones, and eventually icy worlds. Among them, one small fragment, barely a mile wide, was born in the shadowed outer reaches of that protoplanetary ring. For millions of years, it circled its parent star until gravity, that patient sculptor, altered its fate. Perhaps a giant planet formed nearby, its mass disturbing the balance of orbits. Perhaps a passing star brushed the system, tugging gently at the fragile architecture. Whatever the cause, one encounter changed everything. The fragment was thrown outward faster and faster until it escaped. It left home, forever carrying within its core the chemistry of its birthplace, locked away in layers of crystalline ice. For billions of years it drifted through interstellar night. No warmth touched it, no light fell upon it. It became a wanderer gliding between the stars, in temperatures so cold that even hydrogen froze. Its surface darkened as cosmic rays sculpted carbon chains into tar-black crusts. Time became meaningless, distance immeasurable. It was a seed adrift in an endless field, silent, untouched, nearly forgotten, until now. When it entered our solar system, sunlight touched it for the first time since before Earth's oceans existed. In that instant, the frozen gases began to stir. Molecules trapped for ages expanded into vapor. The blackened shell cracked, releasing plumes of crystalline dust, microscopic fragments of alien minerals. To the human eye, it was barely visible, just a faint blur against the stars. But through the instruments of science, it was dazzling. Each photon that left its surface carried encoded within it the chemical signature of a different world. In those photons lay a story, written across the galaxy, a narrative of creation, told not through words, but through wavelengths. As the data poured in, scientists began to compare its composition to our own comets, to Halley, to Tempel 1 to 67P, Churyumov, Gerasimenko, which the Rosetta mission once explored. The resemblance was astonishing. The same carbon-rich organics, the same crystalline silicates, the same frozen water laced with methanol and formaldehyde, the same building blocks from which life itself may have once arisen. The differences, subtle yet persistent, were like dialects of the same universal language, proof that the chemistry of creation is not unique to our sun, but shared throughout the cosmos. The universe, it seems, writes its worlds from the same alphabet of atoms, rearranging them into infinite variations of beauty. In this realization, there is something deeply moving. When we gaze at 3I Atlas, we are looking at material older than our species, older than our planet, perhaps even older than our Sunday. The water sublimating from its surface may have condensed in another system before Earth was born. The carbon in its dust may have been forged in a supernova before our galaxy completed even one of its grand rotations. Every grain that escapes its surface is a messenger from deep time, a crystal from another dawn. The light that reflects from its coma, faint bluish, almost ghostly, is the same sunlight that falls upon our oceans. For a brief moment, our star and its star share a connection through this drifting body of ice and stone. Two distant systems, once strangers, now linked by a single beam of light bouncing between them. There is quiet poetry in that, a cosmic handshake across billions of years. As 3I Atlas rounded the sun and began to drift outward again, its activity waned. The jets slowed, the surface cooled, and the bright haze of its coma faded into stillness. But before it dimmed completely, instruments captured one final surge of data. The dust it released contained silicate crystals similar to those found in our own comets, yet slightly richer in magnesium. These silicates form only in high-temperature environments close to stars. To find them within a body formed so far from its own sun suggested an exchange, a mixing of inner and outer regions, a dance of heat and cold in the early days of its system. This is one of the great mysteries of planetary formation, how material forged near a star finds its way into the frozen outskirts of its disk. 3I Atlas carried that mystery, written in its structure, a silent record of migration and memory. What is remarkable is that even in its fading, the comet continued to teach. Every observation deepened our understanding of cosmic chemistry. We began to see that interstellar comets are not exotic intruders, but kin members of a shared ancestry stretching across the Milky Way. The same laws that shape one world shape them all. The same elements that sparkle in the tail of a comet glimmer in the cells of living beings. We are in every literal sense made of the same material as these travelers. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were once dust in the disk of some forgotten star. When the scientists compiled their results, they realized that 3I Atlas was more than just a comet from another system. It was evidence of connection, a fragment that proved the galaxy is one continuous ecosystem, recycling its elements endlessly. The hydrogen atoms in its ices may have once belonged to the same molecular cloud that gave birth to our Sunday. In the Milky Way's great cycle, matter never stays home. It drifts, transforms, and returns in another form, another time, another place. In that sense, 3I Atlas is not foreign. It is familiar. It is family. At night, the observatories that had followed it for months finally turned their attention elsewhere. The data was stored. The analyses completed. The telescopes repointed toward other targets. Supernova remnants, variable stars, distant galaxies. Yet for those who had watched it pass, the memory lingered like an afterimage. To look at something that has crossed the galaxy, that has existed since before our history began, is to feel time itself stretch open. It humbles and uplifts all at once. And though the world soon moved on, the comet remained in its slow retreat, gliding back toward the outer darkness. Beyond Jupiter, its activity ceased entirely. By the time it reached the orbit of Neptune, it had become inert, a cold ember in the vast expanse, reflecting only the faintest sunlight. But within its core, untouched by heat, the crystalline layers of alien ice remained intact. Those layers hold secrets. We can only imagine isotopic signatures of another sun, minerals shaped by different temperatures and magnetic fields. Perhaps even the frozen remnants of complex organic molecules, the raw materials of life. One can imagine in a poetic sense that 3I Atlas carries memories, not in consciousness but in structure. Each atom within it has experienced the birth and death of stars, the collapse of clouds, the slow churn of galactic time. When we study such an object, we are not just learning about it. We are reading the autobiography of the universe. The dust it releases is the same dust that once drifted through the first nebulae after the Big Bang, dust that eventually formed stars, planets, oceans, and the very instruments that now study it. And so when the final images of 3I Atlas were taken, as it became nothing more than a dim smudge in the night, the astronomers knew they were watching the end of a chapter, but not the end of the story. The crystals it left behind will continue to drift through the solar wind, perhaps falling into our own comets, perhaps one day reaching Earth as microscopic grains of alien dust. In that way, the story comes full circle. The material of another world may one day settle upon ours, unnoticed, blending into the soil, into the sea, into us. It is a humbling thought that we are built from the same stardust that drifts through space as comets like this one, that every breath we take, every heartbeat, every dream carries the echo of interstellar origins. 3I Atlas is not simply an object that passed through our skies. It is a reminder that everything in the universe is connected, that all journeys, however distant, are part of the same unbroken thread of existence. The discovery of 3I Atlas was on the surface an astronomical event, a data point among data points, a curiosity of trajectory and velocity. But beneath the mathematics and the spectral graphs, it became something more intimate, a mirror for humanity itself. Every eye turned skyward, from observatories on mountain summits to classrooms and backyards around the world, was united by a single feeling, a quiet awareness that we were in that moment participants in something far greater than ourselves. For all our boundaries and divisions, for all the noise and movement of our days, we are still a species that looks up, searching for meaning in the dark. When word of the interstellar visitor spread across scientific networks, there was no rush of sensationalism, no cry of alarm. Instead, there was wonder. Astronomers in Hawaii exchanged data with their counterparts in Chile, South Africa, and Australia. Teams at NASA compared orbital calculations with those from the European Space Agency. Amateur astronomers, some with modest backyard telescopes, joined in, eager to contribute their small slices of sky. For a brief moment, humanity moved in rhythm, bound not by politics or profit, but by curiosity. The shared act of looking became a quiet form of unity. In observatories perched above oceans of cloud, night after night domes opened like petals under starlight. Computers synchronized across time zones. Images flowed through fiber optic cables spanning continents. A researcher in Cape Town would capture the faint trace of the object just before dawn, sending data northward. Hours later, as night fell over California, another telescope picked up where the southern skies had left off. Around the planet, light gathered by 100 mirrors formed a single continuous observation. Each pixel, each photon, each mathematical refinement became a part of a collective heartbeat, the pulse of a species watching its universe unfold. Outside those walls of instruments and equations, the human story continued. People commuted lights, filled the cities and oceans, turned with the tides. Yet somewhere within that everyday hum, an invisible thread connected us all to that drifting speck of light. It was a thread woven from curiosity, from wonder, from the recognition that we are not isolated creatures, but extensions of a cosmos that has been creating for billions of years. 3i Atlas, in all its silence, reminded us that every question we ask of the universe is also a question about ourselves. As telescopes tracked its flight, astronomers refined their models to a precision that bordered on poetry. They could trace its position with errors smaller than a mile. They could estimate the sunlight scattering off its dust to within fractions of a percent. They could calculate the curve of its escape as it climbed away from the sun's gravity, following the subtle arc of a hyperbolic path. These calculations weren't just numbers. They were gestures of understanding, proof that the human mind, fragile and finite, could reach across the infinite and make sense of what it touched. And yet, even amid the precision, there was emotion. The scientists who observed the comet spoke in the same language as poets. They described its glow as ghost-like, its movement as effortless, its existence as a whisper in the void. One astronomer wrote in her log, "It is leaving us, and I already miss it." The data, objective as it was, could not hide the humanity behind it. To study the cosmos is to be moved by it, to feel in the act of measurement both the thrill of discovery and the ache of impermanence. For those few months, 3i Atlas became a shared story. Journalists wrote of the messenger from another star. Children in classrooms traced its path on posters of the solar system. Artists painted it, musicians composed for it. Poets described it as a breath between galaxies. Its beauty lay not in brightness or scale. It was no dazzling comet with a sweeping tail, but in what it represented, a connection across unimaginable distance. It was in its own way proof that the universe is porous, that the walls between worlds are illusions, and that creation is a dialogue written in light and motion. But the most beautiful aspect of this discovery was not what the comet revealed about the galaxy, it was what it revealed about us. Humanity, in its collective act of watching, demonstrated something rare and sacred: patience. The work was not hurried nor dramatic. It was quiet, methodical, reverent. Observers spent long nights beneath cold skies, adjusting instruments, logging coordinates, waiting for faint signals to appear. They did not rush to conclusions. They let the evidence speak. And in that stillness, they honored the very thing they were studying: the slow, dignified rhythm of the cosmos itself. Each image gathered added another layer to the narrative. The curve of the orbit grew clearer, the variations in brightness more defined. The data, when overlaid and analyzed, began to form a picture not just of 3I Atlas, but of the space between stars, a medium so thin it might seem empty and yet rich with drifting material. The interstellar dust that the object carried was evidence that the galaxy itself is alive with movement and exchange. Matter passes between systems like pollen in the wind, spreading the elements of life from one cradle to another. In this realization lay something profoundly hopeful. If matter travels freely across the Milky Way, then so too do the ingredients of possibility. Life, perhaps, is not confined to single stars, but part of the galaxy's larger pattern, a continuity that echoes from sun to sun. For the scientists who devoted their lives to studying such things, that hope was not a fantasy, but a logical conclusion. In the same way that seeds drift across oceans to find new shores, molecules drift between stars to find new worlds. Every interstellar visitor, like Atlas, becomes proof of the continuity of creation. A message that what begins in one place can take root in another. The hydrogen and carbon locked in that comet's ice may one day form part of another planet, another sea, another living being. To understand that is to see life not as an isolated miracle, but as the natural flowering of a universe that refuses to remain still. Meanwhile, the images continued to arrive. As 3I Atlas passed its perihelion, the point of closest approach to the Sun, it flared briefly its coma, expanding in a delicate haze of vaporized ice. The light curve rose, then faded, as though the object were taking one last breath before leaving. Observers in both hemispheres caught its fading trail, recording it in exposures measured not in minutes but in hours. The brightness dropped, and the faint green hue that once haloed the nucleus dissipated into invisibility. The traveler was departing. Its orbit would carry it beyond the reach of our telescopes by year's end. Yet even as it disappeared, humanity's response remained ongoing. Data centers archived terabytes of observations, ensuring that future generations could reanalyze the event with tools not yet invented. The digital record of its passage became a time capsule, a preserved heartbeat of discovery. In a sense, it was our way of keeping it close. Though the object would vanish the light it reflected had already been captured, translated, remembered. Its story was now part of ours, and that is perhaps the truest meaning of this chapter of human science. It is not only about the discovery itself, but about the act of bearing witness. In watching 3I Atlas, we remembered that our role in the cosmos is not to dominate, but to observe, to be the conscious part of the universe that notices, records, and wonders. The instruments we build, the equations we write, and the stories we tell are all expressions of one instinct: to understand where we are in the vastness of things. As days turned to weeks and the comet grew fainter, something subtle but lasting took hold in those who had followed it from the start. They began to speak of the experience not in scientific terms, but in personal ones. They described feeling connected to the Earth, to the stars, to each other. One astronomer said that every time she looked at the data, she imagined a thread of light stretching from the comet to her own heart. A metaphor perhaps, but an honest one. Another confessed that he had never before felt so small or so grateful to be part of something infinite. Such confessions might never make it into scientific papers, but they live on in the quiet spaces between facts, where truth and emotion meet. The journey of humanity, then, is not only about exploration or survival. It is about learning to listen to the skies, to the earth, to each other. The discovery of an interstellar object is a scientific milestone. Yes, but also a spiritual mirror. It reminds us that we are temporary, yet significant, finite, yet connected to the infinite. It invites us to step outside ourselves for a moment and see the continuity of existence from another vantage, the perspective of a drifting grain of ice that has crossed the galaxy simply because motion is its nature. And so, as 3I Atlas fades into the distance, humanity remains behind, still watching, still learning, still dreaming. We return to our daily lives, to our screens and streets and seasons, but something in us has changed. We have glimpsed, if only for an instant, the quiet communion of all things. The comet's passage is over, but its echo remains a soft reminder that our shared curiosity is the greatest force we possess. The night skies continue their eternal rotation. New stars rise, others fade. Instruments await the next anomaly, the next faint glimmer that might turn out to be another messenger. But tonight, perhaps, someone stands on a rooftop or a field, looking upward, breathing in the same starlight that once touched 3I Atlas. Somewhere, another world spins beneath another sky, and its beings too may be looking out, wondering if they are alone. Between those gazes lies the thread of unity, invisible yet unbreakable. And now, as the universe drifts back into silence, may your mind rest in the calm between stars. The moment of parting arrives quietly. There are no sounds in space, no curtain to close, no final act to announce the end. Only fading light, only distance. In the weeks after its closest passage 3I Atlas began to dim first. Slowly, then with increasing swiftness, until even the most sensitive instruments struggled to find its faint signature against the vast backdrop of the cosmos. What had once glowed softly, reflecting sunlight across millions of miles, now receded into invisibility. The universe was reclaiming its traveler, folding it gently back into the black silence from which it came. Astronomers, though accustomed to the impermanence of celestial events, felt a kind of ache. They had followed the object since its discovery night after night, charting its position, refining its orbit, learning its rhythm. They had given it attention, patience language. They had watched it emerge, brighten, and now inevitably disappear. In scientific terms, the observation window was closing. In human terms, it felt like saying goodbye to something both fragile and eternal. The object itself remained unchanged by their affection, of course. But the watchers were not. They had glimpsed a world older than memory, a messenger from time beyond their comprehension. And it had passed through their lives like a shadow over still water. By the start of winter in 2025, 3I Atlas had moved beyond Jupiter's orbit, faint as a whisper of light. Telescopes turned toward it one by one, capturing final images before the data fell below detection thresholds. At last, when it was more than 1 billion miles from the Sun, it vanished from all human instruments. The last photons it sent toward Earth would take over an hour to arrive, each carrying a memory of reflected sunlight from a world we would never see again. When the final observation was logged, the astronomers recorded the time, the coordinates, and the magnitude. Magnitude 24.5, an ember in the void. The file was archived, the data secured, the line of code entered. And then it was done. Yet the end of a sighting is never truly the end of a story. In the following months, teams across the world analyzed the accumulated data. They ran simulations tracing the object's path backward through space, calculating where it might have come from. The models suggested that 3I Atlas likely originated in the galactic plane, perhaps near the constellation of Lyra, traveling for millions of years before crossing our Sun's domain. Somewhere long ago, a star had cast it adrift, a forgotten act of celestial balance that by sheer chance sent it on a course that intersected with ours. In tracing its path, astronomers were tracing time itself, peeling back the layers of motion and gravity that tie all things together. Somewhere in that tracing, a quiet realization emerged. The path of 3I Atlas was not unique. It was one of countless billions of fragments moving through the galaxy, each following its own silent trajectory, each indifferent to the tiny beings who for a brief span notice its passing. Our solar system, for all its seeming grandeur, is just a speck in a field of motion. The interstellar space between stars is not emptiness, but ocean, an ocean through which ice and dust, memory and light drift endlessly. The journey of 3I Atlas is our own, a movement through darkness, illuminated briefly by the touch of a single star. Scientists often speak of closure, but astronomy rarely grants it. There is no way to follow such an object forever, no way to hold on as it disappears into the black. The best one can do is measure record and let go. And so they did. The last images were posted to archives, the last papers drafted, the final graphs drawn. Then the telescopes turned to new targets, the computers recalibrated. The cycle began again. In the end, discovery gives way to continuity. The stars remain, the watchers continue, and the universe goes on. But within that continuity lies something gentle and profound, the recognition that everything passes, and in passing everything connects. For the astronomers who spent months watching that faint light, there was a shared understanding that science is not about possession, it is about witness. They could not keep the comet, could not alter its fate, but they could see it. And in seeing it, they became part of its story. Observation is in its purest form an act of reverence. To look at something so far away and know it exists is to honor both it and oneself. As winter deepened and the skies over Hawaii grew wet with rain, the domes that had once tracked 3I Atlas closed for maintenance. The wind across Mauna Loa carried the scent of salt and volcanic soil. The nights were quieter now, their silence less full of purpose. Yet even in the absence of the comet, its presence lingered in memory. There are discoveries that fade quickly, consumed by the next headline, and there are those that leave a trace in the soul. This was the latter. It was not only a scientific event, it was a meditation on distance, impermanence, and the quiet generosity of the cosmos. Elsewhere, far from the instruments that once watched it, 3I Atlas continued its journey outward. It would never stop, never slow, never turn back. At its current speed, roughly 45 miles per second, it would cross the boundary of the heliosphere within a decade, entering true interstellar space once more. Beyond that, it would glide for eons through the cold, thin medium between stars. It might pass within sight of another system in 1,000,000 years, or perhaps drift forever in the galactic night, unseen. Its path would curve gently under the pull of the Milky Way's mass, orbiting the galactic center in a cycle so long it makes human history seem like a heartbeat. And somewhere out there, other travelers like Oumuamua, like Borisov, are doing the same. Each one a spark, each one a page from the same universal script. Together, they form an invisible constellation, a migration of matter that binds every world in quiet kinship. The galaxies spin, stars are born and die, but the fragments endure. They drift endlessly, scattering the seeds of possibility. When we discover them, we are not just studying objects, we are meeting relatives in the long genealogy of creation. There is a kind of beauty in letting go. As 3I Atlas vanished from sight, astronomers turned their attention inward toward reflection. They spoke of perspective, how the comet reminded them that our lives, though brief, are part of something timeless. It is easy on this small blue planet to forget the scale of existence, to imagine that our stories are central. But looking into the deep sky restores balance. Out there, in the boundless dark distance and time become equal forces, erasing ego and replacing it with awe. The farewell then was not a loss, but an offering. It was a moment of recognition, a reminder that beauty does not require permanence. The comet came, shone faintly, and left. Its impermanence is its lesson. We too are travelers existing for a brief passage of light, before fading into the larger pattern. To see that truth reflected in the motion of a comet is to feel the universe speak in its softest voice. One night, long after the last observation had been made, one of the scientists returned to the observatory. The sky was clear again, sharp with stars. She stood alone outside the dome, looking toward the direction where the comet had last been seen. There was nothing there now, no glow, no trace. But she imagined it still, a tiny speck receding into infinity. For a moment, she felt an overwhelming peace. "It's all right," she whispered. "Keep going." And in that quiet, under the hum of the wind, it seemed as if the universe replied. The story of 3I Atlas is not a story of discovery alone. It is a story of patience, humility, and faith in the unseen. It reminds us that not all wonder can be held, not all truth can be possessed. Some must simply be witnessed and released. The comet's departure marks not an end, but a return to stillness, to perspective, to the understanding that the universe is always in motion, and that we are lucky to glimpse even a fragment of its dance. And so it goes. The traveler fades, the observers turn homeward, and the great wheel of stars continues its slow rotation above. The sky remains unchanged to the casual eye, yet for those who watched it will never look the same again. Somewhere in that vast expanse, a tiny, cold fragment glides forever, carrying with it the memory of our sun's light and the gaze of those who once saw it. And now, as the universe drifts back into silence, may your mind rest in the calm between stars. The night sky has always been our oldest companion. Long before we built telescopes, long before we learned to measure the heavens, we looked up and wondered. The same stars that guided ancient navigators still shimmer above us now. The same Milky Way that arched over the first humans glows above our cities, though dimmed by the haze of light. And somewhere beyond that haze, somewhere beyond the faintest edge of our vision, the traveler we once called Three-Eye Atlas drifts, still silent, solitary, unbroken. It is gone from our sight, but not from our story. Every era of human civilization has measured itself against the stars. The Babylonians etched the constellations into clay. The Greeks imagined myths, written among them stories of loss, transformation, and eternity. Polynesian voyagers read the night like a map, steering by the pattern of light on open seas. And now we point vast mirrors at the sky, translating starlight into data, motion, and form. Yet in every age, beneath every method, the impulse is the same: to seek meaning in what lies beyond us. The cosmos has always been our greatest mirror, and in that reflection, we glimpse both our fragility and our endurance. For those who followed Three-Eye Atlas, the months after its disappearance felt strangely quiet. The screens that once glowed with new coordinates now displayed other targets. The charts and models, though elegant, had become routine again. Galaxies catalogued, planets counted, spectra compared. But something had shifted in the hearts of those who had watched the interstellar visitor pass. They had seen the universe not as an abstraction, but as a living continuum. A comet from another sun had swept through our solar neighborhood, and humanity had noticed. In that noticing, something inside us had grown. It is easy, in an age of constant information, to forget what a miracle attention is. The act of looking, truly looking, requires stillness. It demands humility, and that is what astronomy teaches best: patience, silence, and awe. To study the stars is to participate in time itself, to measure moments in light years and destinies in rotations. The observer becomes part of the cosmos simply by witnessing it. The eye and the sky complete each other. Perception becomes a form of communion. Every photon that entered our telescopes during Three-Eye Atlas's passage carried not just information, but intimacy. Those tiny messengers of light traveled millions of miles, bouncing from a comet's frozen surface into the mirrors of our instruments, into our retinas, into our minds. They connected us across unimaginable distance to a fragment of matter that had once circled another star. To know that connection is to feel the immensity of belonging. We are not separate from the universe. We are the universe becoming aware of itself. When astronomers speak among themselves late at night, they sometimes describe their work as listening to light. We listen, to the faint murmur of photons, to the whisper of gravity, to the distant echoes of creation. And every now and then the universe speaks more clearly in a supernova, a planet, a comet from another system. These are the moments when the cosmos reminds us that discovery is not conquest but conversation. The story of 3I Atlas became in time one of those conversations that changed the way we think about our place among the stars. It confirmed that our solar system is not isolated, but open, that material from other suns can drift into our skies. It proved that the galaxy itself is an ecosystem of exchange, recycling dust and ice, the way an ocean circulates water. It hinted too at something larger, that the ingredients of life might not be confined to one world, one sun, or one chance. Every comet, every wandering stone is a vessel of potential. And in that realization lies a quiet kind of faith, not religious but cosmic, that the story of creation is universal. There is a comfort in that thought. For if the same chemistry that gave rise to Earth can be found in the tail of an interstellar comet, then we are part of a continuity far older and grander than our brief history. The hydrogen in our blood may once have burned in the heart of a forgotten star. The oxygen we breathe may have drifted through a nebula before the first planet formed. We are not observers standing apart. We are participants in the great unfolding of matter and energy. To look up is to look inward, to recognize the kinship between the dust of space and the dust of our own bones. And yet, even as we understand this scientifically, there is still emotion in the act of seeing. When we watch a comet fade into the dark, we feel loss. When we measure its orbit and know it will never return, we feel longing. These feelings do not contradict science. They complete it. They remind us that knowledge without wonder is incomplete, that understanding the universe means loving it too. Every great discovery, from Galileo's moons to Hubble's galaxies to Atlas's passing light, carries both intellect and tenderness. For a time after 3I Atlas vanished, the astronomers who had tracked it met online to discuss the final data. They spoke of orbital mechanics, spectral calibration, and isotopic ratios, but beneath the surface, their words carried something deeper. They were talking about meaning, about beauty, about the privilege of being alive in a universe where such events can happen. One scientist wrote later in her journal, "The universe doesn't need us to watch it, but we are lucky that we can." The interstellar visitor may be gone, but it left us with a lesson that no data point can quantify, that impermanence is not the opposite of eternity, but its expression. Everything moves, everything changes, everything returns in another form. The comet's atoms will wander the galaxy long after our species has evolved or vanished, just as the atoms that form us once wandered through stars that are now gone. The cycle is perfect, the pattern complete. We are all part of that endless migration of matter and meaning. And so the telescopes wait. The skies turn. Somewhere, in the black distance, another fragment of another world is already on its way, a new traveler crossing the invisible boundaries between suns. We do not yet know its name, its shape, or its timing, but we will see it, because we always look up. It is what we do. It is what defines us, the quiet courage of curiosity. When that next faint signal appears, When another small light moves across the field of stars, someone will notice. A researcher at a console, a student watching the sky, a person standing outside unable to sleep gazing upward. And once again, humanity will listen to. Light will measure, will wonder. The cycle will begin anew. Discovery will become reflection. Reflection will become gratitude. And gratitude will become peace. To the dreamers, the scientists, the poets, the listeners. To those who find in the dark, not fear, but connection. For in that darkness lies everything. We are history, hope, and the infinite possibility of what comes next. And now, as the universe drifts back into silence, may your mind rest in the calm between stars. And now the traveler is gone beyond our sight, beyond our instruments, but not beyond our hearts. Its light has faded, yet the memory of its passage lingers like the last note of a song that hums long after it ends. Through its journey, we have seen not just an object of ice and dust, but a reflection of ourselves, brief, fragile, luminous. The cosmos in its infinite patience reminds us that every ending is only another turning, another quiet continuation. The atoms that formed 3I Atlas move onward, just as we do, carried by the same cosmic tide that connects all things. So rest now beneath the calm of the night. Let your thoughts drift where stars are born, and silence is eternal. And if you wish to wander further, let curiosity guide your dreams. There are always more quiet wonders waiting beyond the dark.